Hello guys, and welcome once more to the GCE Math panel and Math 24 Super Channel online. This lesson is lesson 1E of A-level mathematics, and it is on logarithms, proofs and equations on logarithms and exponential functions. Welcome. Please stay tuned, subscribe and follow this lesson to the end. You can leave your comments, your likes and so on, and equally attempt the challenge at the end of this question. Stay tuned. We'll start by looking at the laws of logarithms. The laws of logarithms. And the first law of logarithm states that log xy base a equals log x base a plus log y base a. So to prove this law, we first of all say let or suppose that x is equal to a to the power m, where a is a positive number and y is equal to a to the power n. When we take the product of these numbers, or before doing that, if we have to convert x equals a to the power m to logarithmic form, we will have log x, this x, base a, the base remains the same whether for exponential or logarithmic form, the same base, is equal to the power. So this will be equal to the power on the right hand side. Similarly, log y base a equals n. Now taking the product of these two numbers, x and y, you have x times y will be equal to a to the power m times a to the power n. And from the laws of indices, since the bases are the same, we can add the powers, and this gives us a to the power m plus n. We can take log base a on both sides, and when we take log base a on both sides, we will have log xy base a is equal to log a to the power m plus n base a. Similarly, from the third law of logarithms, we can bring this in front. So this will give us mn times log a base a. Similarly, from the laws of logarithms, log a base a is equal to 1, or even from exponential functions, n number raised to the power 1 is itself. So this will just give us m plus n. However, we know from here that m is equal to log x base a and n is equal to log y base a. So we replace m and n by these values, and this gives us this first law of logarithms as required. The second law is similar to this one, just with a few modifications, that is for subtraction or for division. So the second law, we are to prove that log x divided by y base a is equal to log x minus log y, where the base is a. So the first thing, we suppose that x is equal to a to the power m and y is equal to a to the power n, such that when we convert, you see that this first step is the same as the previous first step. In logarithmic form, you have log x base a equals m and log y base a equals n, such that when we get the quotient of these two, that's x divided by y, will be equal to a to the power m divided by a to the power n. And from the second law of indices, this one can be written as a to the power m minus n. So if we take log base a on both sides, this will give us log base a, x divided by y base a is equal to log a to the power m minus n base a. But for this right hand side, you can bring the m minus n in front. Putting it in brackets, we will have m minus n into log a base a. But log a base a is equal to 1. So this gives us m minus n, which we can replace with these values up here. When we replace these values, we have log x base a minus log y base a as required. This is the second law. So if you know how to prove the second law, the first law, the second one is very easy, and vice versa. The third law, or the third proof you are going to be having here, is not difficult as well. It's easy. Here we have to prove that log 1 over y base a is equal to minus log y base a. This one you can do it directly by expansion. So just simplifying the left hand side, we will have log 1 over y base a is equal to log 1 minus log y. But the log of 1 to any base is 0. So when you simplify this, it gives us the answer directly, which is equal to minus log y base a as required. So this law is very easy to prove. Let's look at the next law. This law is for negative exponents. Now let's look at this law. If x is greater than 0, prove that log x to the power n base a is equal to n log a x. This one has some tricks in it, so you have to focus. You start by saying let x to the power n base a be equal to, what I'll do here is I will replace this x here by a constant raised to a certain power. By a constant, I'm going to replace this x by a constant raised to a certain power. So I'll replace it with a to the power c. I'll use this same base because I will need it. I'm using the base that is here and raising it to a power c. So I've replaced x by a to the power c. I'll continue with this same power n. I now raise the power n. And when this one is simplified, this will give us log a to the power cn base a. And as we have said that x is equal to a to the power c here, in logarithmic form, we can actually simplify it. So in this case now, we will have, bringing these powers in front, this cn in front, we have cn log a base a, and that will give us just cn. But what's the value of c? To get the value of c, we have to convert this to exponential form, and that will give us log x base a equals c. So our c here is equal to log x base a. So this gives us n times log x base a as required. So this law is actually short but seems a bit complicated. Just a few steps but looks a bit complicated. So you have to master this one. Let's move on to the next or the last law for this page before we continue the other aspects of the lesson. This other one requires the change of base to prove that log c base b equals log c base a over log b base a. This change of base is very, very important when you be looking at integration and differentiation. Why? Because we must be working with the natural logarithm, and at times some functions are given in the form of the normal base 10. So you have to convert to the exponential natural number, or e. So this change of base comes in handy, and even at times to solve some quadratic equations involving logarithms or indices, this law comes in powerfully. So we say let x be equal to log c base b. Let our x be equal to this log c base b. This one should be equal to x. From here, converting it to exponential, we will have b to the power x equals c. And when we take log a, that's log base a on both sides, we will have, that's for this c equals b to the power x, we will have log c base a equals log b to the power x base a. Bringing the x in front, we obtain this quantity, and we can now solve for x. When we make x the subject of the formula, we will have x to be equal to log a, log c base a over log b base a. This one is also very easy, though it looks complicated a bit. However, we know that our x is equal to log c base b, so we replace it by that value. This is it here. We replace it by this value that we have above here, and we have that proof. This one is called the change of base. In subsequent lessons, we will see how important this is in solving equations on quadratics involving logarithms and indices, or we equally see this under the lesson of conceived quadratics. Note that if the base is raised to a power, then it can be simplified as follows. As you can see here, the base here a is raised to the power n. You can bring this power in front, but it will not follow the same rule as when the power is at this c. So to bring a power in front from a given base, we take 1 over that power. So this will be equal to 1 over n log c base a. This is one of the laws of logarithm at advanced level. You will not talk about this law at ordinary level, except perhaps in additional maths. The next thing we have to note is, alright, so we can actually prove this law above as well. Let's look at the next thing we have to consider. Note equally that when the base is 10, then we can leave out the base completely. So if a log is written without the base, then it means that the base is 10. As long as you see LOG, know that the base is 10 if the base is not there. So you have the choice when the base is there, when the base is 10. So whenever the base is 10, it can be written without the base. If the base is not 10, it must be written. The next thing we have to note is the natural logarithm, also known as ln. The natural logarithm, also known as ln. The ln means that the base is the natural number e. So if you have log x base e, where e is the natural number, it can be written as ln x. It's read ln x. So you can start the ln means that without the e. So whenever the base is e, you have that ln. And this ln is very important when we are differentiating and when we are integrating. So that's one of the most important aspects of this lesson. Another point is converting from log to ln. When you have to convert from log to ln, you see that the change of base comes in handy. So any log x to base a, to convert it to ln, we just have to use the change of base. Since we have ln here, it means that the base is e. And this is what we just saw for change of base above. This x is now a numerator, a is a denominator, the new base is now e. So this gives us ln. So we are going to see most of this in the tutorials that we have at the end of this chapter 1. We will see most of these things there and application exercises and their corrections on the page, either gcemathspanel.com or gcemathspanel.blogspot.com. You see all of them there, or on Google Sites. I would like to discuss some properties of logarithmic functions, though we will still see these properties when we move to functions itself. But let's just discuss some properties of these functions. If you look at this curve that we have here, we have the curve of y equals log x base 3, which is logarithm, and the curve of y equals 3 to the power x, which is exponential. For the exponential, this is the curve. This first curve is exponential. And for the logarithm, we see this other curve below. Now, when you have the graph of y equals log x base 3, and they ask you for the graph of 3 to the power x, you just have to reflect it on the line y equals x, and you have the other one. When you look critically, you see that we here the coordinates are 2 and 9 for the exponential function. When you reflect it, what becomes of the coordinates? 9, 2. The same with 1, 3 and 3, 1. And all the other points are the same. So when you reflect the graph of logarithm on the line y equals x, you have the corresponding graph of the exponential function. So those are the most important things to note. You can get this note from the blog. Online preparation class. You can get the notes there, it's free. Another thing to note is when we raise e to ln x, even log is the same thing. So the base here is e. This ln here, the base of ln is e. So e to the ln anything is that same thing. E ln x is x. E ln y is y. E ln f of x is f of x. Let's also look at it for logarithms. A log x is also x. So when because the base here is a, the base here is equally a. So it's equal to x. So for ln or log, because this one mostly comes in questions and I see it almost every year. So we have a log x base a is equal to x. Take note of this. Let's take some examples. Solve the following. You have log 3 to the power x equals log 5. Now with this particular equation, let's see what we have. So we can have this log 3 to the power x, you can bring the x in front. So you have x log 3 is equal to log 5. Making x the subject of the formula, that's what we have. Another students can have this answer as log 5 base 3. That's from change of base, log 5 base 3. Converting back from base 10 to base 3. Answer is still correct. And note this type of answers. These type of things are simple and can easily be found in multiple choice. With this second one, we do the same thing. We bring the power in front. And this is the solution that we will have after solving. So you have to solve this one. This is the answer. We have a lot of exercises and their solutions follow. So these are the answers. Please, it is very important to solve all of this. I would like to lay emphasis on I, J, K, H, and L. I would like to lay emphasis. If you don't solve all, you must solve these ones. And even Z, make sure you solve them and see if you have these results. And here you equally have some exercises. The answers are there. You are just to simplify the left hand side and show that it's equal to the right hand side. It's just to simplify using those laws of logarithm. Like the first one, log 64 base 8. You know that 64 is the same as 8 to the power 2. So bring the 2 in front, you have 2 log 8 base 8, which is equal to 2. So simplify these ones as well. Make sure you simplify for all of these ones. And here you can equally compare the graphs of log this and that. The first one is compare the graph of log x base 2 and log 3 x base 3. So we start for these graphs. For x greater than 1, the graph of log x base 3 is steeper or greater or higher than that of log x base 2. But for the value of x less than 1 at this point that the intersect is 1, for x less than 1, it is the graph of log x base 2 that is steeper than the graph of log x base 3. The second question is for us to show that to simplify these expressions, and when you simplify, these are the values that we have, the answers are there. You just need to simplify. You simplify these are the answers. It's part of the tutorial. So get this note from the page, GCE Math Panel online classes. Go there, go to advanced level. You get this note under this particular lesson and you solve these equations. Here equally, you have been given log 2 base 7 is equal to a, log 3 base 7 is equal to beta, and log 5 base 7 is equal to gamma to express everything that's been given here in terms of alpha, beta, and gamma. Let's take, for example, the first one. You have log 6 base 7. What I have to do here is to express 6 in terms of 2 and 3, so I can use alpha and beta. So this is what I've done. 6 is the same as 2 times 3. When you use the first law, it's the same as log 2 base 7 plus log 3 base 7. But log 2 base 7 and log 3 base 7 are both alpha and beta, so this gives us the sum. The second, log 75 is the same as log 3 times 25, and this will give us log 3 plus log 7 plus log 5 to the power 2, not 52 here, this 5 to the power 2, and you can bring this 2 in front. This will give us beta plus 2 gamma, and the same 2 is this 15 on 2. And here we have these equations to solve, and the answers are equally on the block. It has been solved for you. You have equations involving logarithms. These are difficult equations. When you solve these ones, these are the results that you obtain. Please go through the equations and solve. And you have these challenges as well. So these are some things equally solve. For those who are with us for the classes, when you solve, you can leave it in the group and we will discuss it there. For others who are just looking at the lesson, you can solve and leave your answer on the link below the video. Thank you so much and stay tuned. We have this challenge that we would like you to take. Solve this challenge. Find the values of x and y for this first, and for this second one, take this challenge. Leave your answers on the link below this video. Thank you so much.